Hi and welcome to Rational Expressions Day 7. Today we're going to be multiplying and dividing rational expressions. And in order to do this, we have a few steps that we must follow. The first one is to factor. We always factor first. And then we cancel, and it says any top with any bottom. What that means is any numerator and any denominator can cancel as long as they look alike. Never two numerators, never two denominators. So never two tops, never two bottoms. Always the top or the bottom. And then you collect and rewrite your remaining terms. For number 1, I actually cannot factor that question. Okay, but I can simplify it. So I have 6m n squared. And if I square what's in the parentheses, I will have 4w squared times 2w squared over, if I square what's in the parentheses, 9m squared n squared. Now I just need to cancel out what they have in common. I see a w squared here and a w squared here, so they cancel out. I see an n squared here and an n squared there, so they cancel out. I see an m with an m squared, so my m squared becomes m, and my m cancels out completely. And let's see, my 2 will cancel with my 4, and it will become a 2. And then my 6 and 9 both have a 3 in common, so this becomes a 2, and this becomes a 3. And I have another 2 here, and another 2 there. So when I collect my terms all across the top, everything canceled out, so I just have 1s across the top when I multiply, so I have 1 over. On the bottom, I have 1s and 3m's. So when I multiply, I have 3m. So 1 over 3m. For number 2, I need to factor and cancel. So the very first step is to look at the fact that I have a squared, and remember that that means write it twice. So this becomes x plus 1 times x plus 1 over, if I look at my denominator, I have a GCF of x, and then I'm left with x squared minus 1. However, we know that that is a difference of two perfect squares. So I'm just going to write it as x on the outside, x plus 1, x minus 1. Okay, so x plus 1, x minus 1 times, right, the x minus 1 twice, all over x. So here I have an x minus 1, and that'll cancel out with one of those x minus 1s. Here I have an x plus 1, and it'll cancel out with one of those x plus 1s. And there's really nothing else I see that I can cancel. So I'm left with x plus 1 times x minus 1. Oh. Okay, so x plus 1, x minus 1. And then in the denominators, I'm left with x and x, so that makes x squared. Nothing else will cancel, so I'm just left with it is. Notice I'm not actually multiplying my answer when I'm done. I leave it in factored form, and that's perfectly acceptable because I have to reduce all of my problems. All right, for number 3, x squared minus 12x plus 27 is factorable. So it's x and x. Factors of 27 that add up to 12 are 9 and 3, so minus 3 minus 9 over x squared minus 1 is x plus 9, x minus 9 times x plus 9 over 3 minus x. Well, this x minus 1 cancels with that x minus 1. This x plus 9 cancels with this x plus 9. I have x minus 3 and 3 minus x, and that's that opposite thing that we talked about yesterday where there is a negative 1 when you cancel. So this becomes a positive 1, this becomes a negative 1. So I'm left with all 1's in the numerator, and I'm left with negative 1 in the numerator. So when I multiply, I get 1 and negative 1. And when I divide, I get negative 1. Okay? So for dividing, we have steps again. Hang on. We have steps again for my division. 1 is to factor. 2 is stay, change, flip. 3 is to cancel. And 4 is to collect the terms. 1 and 2 can be done together. So you can combine steps 1 and 2 into one step if you'd like to. And that's what I tend to do. So for number 1, I have x minus 2 over 4m. That's not factorable. And neither is 2 minus x over 4m factorable. So there's no factoring. So I stay. That means I keep the first fraction the same. I change my division to multiplication, and then I flip my fraction to its reciprocal. So now I can cancel. So my 4m's cancel. And I have x minus 2 and 2 minus x. That becomes a positive 1. That becomes a negative 1. So I have 1 over negative 1, which is just negative 1. For number 2, I'm actually going to cube what's in there because there's no plus or minus signs inside the parentheses. So I actually need to raise it to the third power, second power, whatever power is on the outside. So if I raise 2y to the third power, I have 8y cubed over 3x squared is 9x squared. Change my division to multiplication. Flip my fraction to 2x squared over 3x squared over 2y cubed. Then I just start to cancel. Y cubed cancels with a y cubed. X squared cancels with an x squared. 2 goes into 4 8 times. 3 goes into 9 3 times. So I am left with just 4 times 1 times 1 times 1, so 4, and just 3 on the bottom in the denominator, so I have 4/3 for my final answer. For number 3, write it twice. So I have m minus 4 times m minus 4 over m squared minus 16 is m plus 4 and m minus 4. Change my division to multiplication. Flip my fraction, so I have m plus 4 over 4 times m minus 4 because that's a GCF. So I have this m minus 4 that cancels out with that m minus 4. This m minus 4 cancels out with that m minus 4. M plus 1 cancels out with m plus 1. So I'm left with just 1's on the top. And don't forget that 4 over there. So I have 4. So I'm left with 1/4. 4 is a little bit trickier just because it's only variables, no numbers involved. But look for GCF. So for the first numerator, I have c squared, and I'm left with c minus y. Over, in the bottom, that is not a GCF, but it is a difference of two perfect squares, so it's c plus y, c minus y. Times, flip my fraction and cancel. They both have a y squared in common. And I'm left with c plus y all over c cubed y. Well, this c plus y cancels with this c plus y. This c minus y cancels with this c minus y. I have c cubed. It's a cubed. It's hard to see. Hang on, let me get that so it looks good. So c cubed. And this is c squared. So c squared becomes 1 and c cubed becomes c. And then I have a y, it becomes 1, and a y squared, that becomes a y. So when all is said and done, I'm just left with y in the numerator. I'm just left with c in the denominator. So I have y over c. So as you can see, multiplication are exactly the same, except for division, you have to do one extra step, which is the stay, change, flip. Keep the first fraction as it is, the stay, change division to multiplication, and flip the fraction to its reciprocal. All right. Good luck with that.